Managing risks in the maritime industry through the application of engineering solutions. Good morning, participants. Welcome to the second day of our exciting conference. Yesterday was loaded with high level of knowledge, and I can assure you that today is not going to be different from what we had yesterday. Our first panel should be coming up in a few minutes from now, but before then, I have two gentlemen with me who should have brought greetings at yesterday's opening of the conference. The two of them are with me at the podium now. Mr. Darwin Telemark, who is the CEO of Antigua Port Authority. And with him is Professor Temi Ologunorisha, who is the Vice Chancellor of Olusegun Agagu University of Science and Technology out of Nigeria. The two of them arrived late yesterday, but we give them the honor to bring greetings from their respective organizations and institutions. So I will invite Mr. Telemark to please come on the podium. You have 2 minutes maximum to bring your greetings. Thank you, sir.
It's not very fair, but anyway. Good morning, CMU. Good morning to industry partners. Good morning to Caribbean people. I bring you greetings first from the Port Authority of Antigua and Barbuda, my chairman, Senator Mary Claire Hurst, and our minister, Prime Minister Gaston Brown. I'm actually here representing the Port Management Association of the Caribbean, of which I am the chairman. And this organization represents 22 ports throughout the entire Caribbean region. We are a part of the maritime landscape. Matter of fact, we are, from a port perspective, from an industry perspective, we manage the ports. And we are very interested in this industry conference. We intend to be here every time there's an industry conference. We see the value in it, and we want to continue to encourage CMU in making this the grand event that it has to be. Our ports require skilled, well-trained leaders, technicians, and very efficient planners. There is no other place in the region where the industry-specific skills are being taught than here at this university in the way that it's being done. And for that, we congratulate CMU, and we trust that this can continue going forward. The CMU is an associate member of PMAC and a very, very important partner in what PMAC is attempting to do around the region. And we value that partnership, and we appreciate all of the support that we get from all of you, not just the leadership from Professor Andrew and Dr. Ajagunna, but from all of the other staff who continue to participate and support what we do at our ports. Thank you very much. I just end by saying your subject, managing risk in the maritime industry through the application of engineering solutions, that cannot be a more well-stated issue. The ports are challenged with an engineering problem. And I'm going to be speaking to Professor Andrew. I think I don't remember her name, the young lady I was just speaking to a while ago. But we have to fix this problem. All the ships are asking us for shore power. The ships consume more shore power than our islands do. It's really an engineering conundrum. How do we fix that? Requires some thoughtful deliberation and some integration throughout the region. And I think I've spoken to you briefly on that. I think we need to pay close attention to it because it won't be too long before we start seeing the impact of us not responding. And I'm hoping that we can get going on that. Thank you again. Happy to be here. Looking forward to participate. Thanks.
Thank you very much, Mr. Telemark. And I must let you know that Mr. Telemark is a past student of CMU. Last year, he was our keynote speaker, and we felt shy this year to ask him to come and do the same thing for us again. He excited us very well last year. And I must also say that both Antigua and Barbuda Port Authority, as well as the Port Management Association of the Caribbean, have been a great supporter of this university over a number of years. And thank you for your support, Mr. Telemark. And I also understand that Mr. Telemark is now enrolled on a doctoral program, which is expected to be completed maybe in another 1.5 to 2 years from now. Thank you very much, sir. At this point, I invite Professor Temi Ologun-Orisha to bring greetings.
Good morning. The organizer of these programs, standing on the existing protocol, I don't know where to start, but let me appreciate the CMU for organizing this conference. This is my first time in Jamaica, but I discovered that Jamaica and Nigeria share the same tropical environment, same weather, the same climate. It's as if I'm in Nigeria, no difference. I'm happy to be here. My coming is very strategic to my university, Olusegun Agago University of Science and Technology. My university is located at the coast, and we are setting up a maritime academy, which is expected to take off next year, September. And we have decided not to look into the Western world for collaboration, but to look into collaboration with CMU, which is the center of excellence, recognized even by the United Nations within the Caribbean. So our partnership is going to be strategic in the sense that I've visited here now, I've seen for myself, and I discovered that we have a lot to do together in terms of assisting my university in the area of manpower training. When we take off, we want to see how to forge alliance in terms of area of visiting professorship. We want to see teaching faculties also working with us, either online or even coming on sabbatical. We want to encourage that in this area of maritime education. And apart from that, the federal government of Nigeria has just approved the establishment of a deep sea port in my state, Ondo State, where the university is located, and maybe a 1 hour drive from my university. That's where the port is going to be located. And so we are looking at CMU as a strategic partner in the area of producing the critical manpower required to drive this development. Because in Nigeria, we don't really have any maritime academy or university. The only one we have is here to produce manpower at graduate level, and that's Maritime University at Delta State. I'm sure Professor Ajagunna knows that one. So there's a huge gap, especially for a country of about 200 million people. So you can see that there's a gap which needs to be filled, and that is why our collaboration is going to be very useful for both parties. On this note, I want to congratulate everybody, and most importantly, CMU for organizing this conference. Thank you very much, and see more of you again.
Thank you very much, Prof. The first MOU between CMU and that university was signed in 2017. That MOU has expired, and then we have a renewed MOU to be signed by our president and the VC visiting with us. Thank you again very much, gentlemen. At this time, I'm going to invite up here with me Professor Anthony Clayton, Mr. Desmond Young, Herona Thompson, and Mr. Norman Tai. They will be our next power panel speakers, and that will be moderated by Professor Anthony Clayton. Professor Anthony Clayton is a professor of Caribbean Sustainable Development at the University of the West Indies, a visiting professor at the Center for Environmental Strategy in the School of Engineering at the University, as the University Scholar at the Jack Gordon Institute for Public Policy within the Stephen Green School of International and Public Affairs at Florida International University. He served as a visiting professor at the Institute of Studies of Science, Technology, and Innovation in the School of Social and Political Studies at the University of Edinburgh. Adjunct Distinguished Professor of Sustainable Development in the Faculty of Business and Management at the University of Technology, and he also served as International Associate of the Center for Social and Environmental Accounting Research in the School of Management at the University of St. Andrews. The profile is a very lengthy one, but I just cut it a little short. But one aspect of his profile that draws my attention is that he manages a large portfolio of research and development projects, and he has served as a panel member of examiner for over 80 PhD candidates. And amongst these 80, I happen to be one of them. Professor Anthony Clayton.
Thank you very much, Ibrahim. Good morning, everybody. I never got a round of applause for being a supervisor before. I thought it was all just hard work. Thank you for coming to this session on the built environment. I'm going to give a little bit of introduction just to explain why this is so important. Thank you, Ibrahim. Over the next 25 years, we're expecting to see the world's population increase by about another 1.5 billion people. And in addition, we're expecting to see continued rate of urban migration. Percentage of the world's population that live in cities is projected to go up from about 55% to closer to 70%. As a result of both of these trends, we think that urban populations are going to increase by about 2.5 billion people by 2050. Now, 2.5 billion is a number it's quite a little hard to encompass. So if you can imagine Mexico City today, a big, vast urban conglomeration with over 20 million inhabitants, 23, 24, we're going to have to build 3 or 4 cities the size of Mexico City every year between now and 2050 to house all those people. On top of that, however, we have about 1 billion people living in areas that we may actually start to lose to rising seas, and we're going to have to rehouse those people as well. What this means is that we could be going into now the fastest phase of urban development that's in human history. If we build those houses the same way that we've been building houses up until now, we're going to contribute enormously to the problems. Today's cities consume about 40 billion tons of materials every year. By 2050, that's going to be closer to 90 billion tons of materials every year. We can't afford this. We're going to have to learn how to build much more cheaply, much more effectively, much more quickly, And the houses that we're going to build are going to have to be much more resource and energy efficient. So the question is, can we meet these challenges? We have with us some excellent panelists who are going to be discussing these and other related questions. Mr. Desmond Young, Ms. Herona Thompson, and Mr. Norman Ty, all of whom are engineers. So please join me in welcoming our first speaker today, Mr. Desmond Young.
Morning, colleagues. I don't have to ask if you're hearing me clearly. I think you are. I am presenting on an area that has been very, very close to my heart. I've been the Jamaica Institution of Engineers representative on the National Disaster Committee for a very extended period. Just came off recently. And so every year when the 1st of June come, I don't know about you, but I get nervous. Because we live in an area that is bombarded, the entire Caribbean exactly, by weather systems. And I'm going to speak to you about the impact of the weather systems on the built environments. You know who I am. I'll start by letting you know that we're an island, and most of our assets, our primary assets, are located right up beside the coastline. Not only our industries, but 70% of our population is also right up and close beside the coastline. And that presents a predicament because every year we have what we refer to as the Atlantic hurricane season. Starts 1st of June and goes to the end of November. And on an average, every 100 years, we peak between August and October with repeated, and I'm going to show you some data from 2 decades that shows you how serious this is. And I'm doing the presentation this way, not really to frighten you, but to make you aware of the risks, and so that whatever mitigation that is required. And it is very clear that CMU is right up there because you are located also very close to the coastline. Now, nothing is wrong with that, but we need to be aware and we need to deal with it. So we have been averaging 1 and sometimes even 2 storms per year for the last 100 years. Most of the time when we speak about weather and hurricanes, we speak about the wind speed. But I don't only want you to focus on the wind speed. I want you to focus on the storm surge and the issues that can be created by just flooding. What I'm saying, it doesn't have to be a severe system. It doesn't have to be a tropical storm. It doesn't have to be a hurricane. What we have seen in recent time, that even normal rainfall creates flooding. But what I want to focus your mind on is the storm surge, because even category 1 can take an average to 4 to 5 feet, and that would cover quite a large portion of our industry. And when you go to category 5, you're talking about greater than 18 feet. And so the decade that I was referring to, it was in the 2000 to the 2010, and that period we saw at least 1 major event every year. The total impact in terms of costs was about $112 billion. And you can see that even when it is not a hurricane, because here I have the May-June flood, and it was 2.47 billion. This is Jamaican dollars. And Tropical Storm Nicole and Tropical Storm Gustav, they weren't hurricanes, but they had severe impact. Overall, to our infrastructure, that same very period, we're talking about 51.7 billion Jamaican dollars, and you can see that even our ports were affected. So you can understand the risk. So I'm not trying to inflate it or overemphasize it. It's a fact, it's a reality. And sitting on that committee every 1st of June, I got nervous because I said, oh Lord,
suppose one of these category 5s touched down, what would happen? And at the same time, we are helping other countries in the Caribbean to analyze the impact of what happened to them after they touched down. So we know. We in that room understand the effect. So 1988, we had Gilbert. And somebody said, oh yes, category 5, maximum wind speed was 298 kilometers per hour. But look at the storm surge, 15 to 20 feet. You understand what that can cause. And I had first-hand knowledge of what happened in Dean. I was one of the first from the team that went into Caribbean Terrace, and I interviewed the owner of that house. And I asked him what happened. And he said he watched the sea take up the sand and just throw it upon the house and just draw everything back out. The Palisades strip was covered. We did some work. You can see it on the right, and that was mitigation. Katrina, more than 20 feet. That's the Mercedes-Benz Arena. We always talk about the damage that it's caused, but the impact on the human life, most of the time we miss it. But in the next decade, we had similar instances, but we didn't have that sort of impact on Jamaica. But for example, Ian caused more than Katrina, and the damage was significant. Sandy hit us, and we had serious issues. Maria. And so, what I'm saying, we are seeing longer drought periods, unpredictable rainfall, more intense events, increased flooding, higher storm surges, more frequent events, increased damages, which in terms of the industry itself leads to more extension of time claims and delays on the construction period. And with all of that impact that I just told you, our GDP for 2022 was only 17.1 billion, so we can't manage anything like that. CMU is located in that region. All of those risks are up to you. And recommendations: improve shoreline protection, concrete roads in the coastal areas, reinforced concrete roofs. This is a project that I was responsible for, and you see we designed coastal protection. The roads in this development are concrete roads, the roof is concrete, and you can see the setback of the development from the shoreline as part of the mitigation. The areas where we had concrete roads post-Sandy that did so much damage, all they did was just clean up the roads. When we had to resurface some of those very areas that normally we have this repetitive cycle. And so that is the issue we face.
Thank you very much, Mr. Young. Of course, raises a question as to why we are still allowing people to build down at water's edge, including in some areas that we expect to lose to rising seas in a few years' time. Let me ask the next speaker to come up. Herona, would you take the floor?
I must say, I think based on Desmond's presentation, I think this is a good way to segment into what I found with my research. So I'm going to just present on what I studied and my research or dissertation research at the University of Leeds that was done in 2020. And I thought it was very good for this conference because we're looking at the maritime space. So for my presentation, as mentioned, I'm an engineer and geologist. And as we continue through the years, we realize that as we are in the Caribbean region, we are a disaster hotspot, especially for climate threats. And we're looking at its impact on humans, but it also has a significant cost for us as a region. And the Caribbean Community Climate Change Center found that if we do not take action, we're looking at these costs representing roughly 10% to 20% or more of our country's GDP. And it's really expensive and really hard to bounce back after such events. So for my research, what's interesting is I'm looking at something new, something different, especially for the region. We look at it the impact of climate change on humans, we look at it on buildings, but what about what we build our buildings on, which is the ground? So there is a lot of new research going in internationally on what is the potential impact of climate change on critical infrastructure. And for this conference, we'd say our ports. But what about the ground and the geotechnical assets that we build on for these ports? So for my research, I decided to look at what would be the potential risks of climate change to select critical infrastructure as well as their ground conditions. For this, I had to look at and determine, okay, which islands I'd like to look at, what kind of infrastructure, and then see if I could test what would be the impact on the critical infrastructure as well as the ground assets. And as Desmond said before, storm surge, and in my case, sea level rise are extremely important. So for the process, I decided to select 3 countries, Jamaica, St. Lucia, and Barbados, and look at around 24 critical facilities, which would comprise of airports, seaports, as well as energy facilities, which are all on the coast. For this research, I used mainly a GIS platform to model the storm surge, or apologies, the sea level rise. Storm surge, of course, is kind of tied into it. And there was a limitation. It was done during COVID. So I think it is extremely important, especially now looking back, that as we continue to do research and as we continue to look at things, that we don't allow certain situations, for example, the pandemic, to hold us back in finding solutions. And I'm really hoping that the research that I've done would encourage others to continue research, continue others to look at what's happening in the Caribbean, and to continue to help to find solutions. So in terms of the Caribbean, especially in terms of climate change, we're looking at greenhouse gases and their contribution to global warming. And we have 2 issues here. We're looking at changes in air temperature and, of course, sea temperatures, which are, of course, fueling all of these climate threats. So what are we looking at? We're looking at an increase in temperature. We're looking at a rise in sea level. One thing that's interesting, I don't really hear a lot of people speaking about, is the increase in ocean acidity and maybe even the chemical change, which is extremely important. We're looking at a temperature change, a change in precipitation. We are also looking at an increase in drought. So the 3 countries I mentioned before were Jamaica, St. Lucia, and Barbados. Many of the critical facilities are on the coastline, but they also have a range, or they're also different in terms of their ground conditions and what type of islands we're working with. So Jamaica and St. Lucia, they'd be mountainous. We're looking at, with Jamaica, especially in Kingston, we're looking at engineered fill, and in Montego Bay, not really engineered fill. We're looking at, St. Lucia, volcanic geology that they're working with. And with Barbados, we're looking at limestone. So 3 different types of geological material. And what was interesting is that with all 3 countries, they're currently in the phase of some form of airport expansion. And in the case of Barbados, they're looking at expanding their energy facilities. And this research is extremely important because while you're looking at expanding, what kind of considerations do you take in place while you're expanding? Because if we continue with the same way we've been doing things, we will have to be in a reactive format. And of course, that takes time, that takes money, that takes planning. Some things that are not easily and readily available to us in the Caribbean. So in looking at geotechnical design, I selected a few: pavements for airports, foundations for energy facilities, and of course, embankments and fill and ground improvement. And just to give an example, here in Kingston, where you have the Port of Kingston, especially the Western Terminal and the Portmore Toll Road, all of that did not exist before the 1990s. It was actually reclaimed land that we're working with. So if we're looking at our port, this is extremely important. For all 3 countries, I separated them into individual zones in order to determine what could be the potential impact. So if you can look on your screen, I decided to model 3 different sea level rise scenarios and look at how it would affect these different zones. And what you're seeing now is Montego Bay. So as I scroll through and you look at the screen and you look at the symbols of the airports, seaports, and energy facilities, you're seeing where the sea level rise or the water is heading into where we have these facilities. And of course, in doing this, my research was looking at a risk-based format. Okay, so how would these affect these facilities at these different sea level rise scenarios? And as you can see, with a lot of red and with a lot of orange, a lot of our facilities are going to be at risk. So I hope that the research that I've done, of course, helps to encourage others to look into these things, as well as to continue research and to continue to see how we in the Caribbean region can help to protect the assets that we have, because they're not only extremely important for our economies, but for our livelihoods. Thank you.
Thank you very much indeed, Ms. Thompson. That was an excellent outline of the scale of the challenge that faces us. Sadly, although it is true that the Caribbean is a potential disaster hotspot, it is also true that the entire population of the Caribbean represents around about 1% at most of the total population that we expect to be adversely affected by climate change, which means that it will be probably the case that we're going to have to find the resources to deal with this ourselves. We can't be waiting for other people to do something. Not when we're talking about large parts of the Middle East, Bangladesh, and so forth, becoming uninhabitable. So we now hear from the man who has the task of actually enabling Jamaica to prepare and adapt to this new future. Mr. Norman Tai, please take the floor.
Such pressure with that statement. Thank you. Is that so? Okay. Not getting. Well, in the meantime, I guess I'll just start. I guess one of the first things, good morning again, everyone. And my topic really was just transportation and the built environment. And I guess we can all agree that transportation impacts and shapes the built environment, as well as the built environment impacts and shapes transportation. So the relationship goes both ways. And my presentation really now is really a high-level discussion or a high-level conversation as to what the multidimensional context of transport will look like when it comes to the built environment. And the first point that I'd like to mention is that anything with transportation, especially in the technical field as engineers, it has to be married with planning. I call it a necessary marriage. You cannot do engineering transportation without some planning. And I guess that's probably one of the biggest issues here, is that we tend to not be the best sometimes in putting forward our plans, but it's definitely one area that we need to overcome. And in planning, the critical question that we tend to ask ourselves, especially when it comes to transportation, is what do we envision for our cities? What do we envision for our urban spaces? And there are a number of terms that I'd like to introduce to you. Or not introduce to you, but I'm sure you're already aware of it. But first of all, we speak of the densities of our urban spaces. What do we want it to look like? Is it going to be compact? Is it going to be a sprawling type of land use? Is it going to be mixed use development? How do we see our city looking like? Then we have to think about our zones. How do we segregate or separate spatially what our urban spaces are? When we talk about our central business districts or commercial areas versus our dormitory regions, or where we live and go to school, versus our industrial areas where our ports are. How do we organize that space? And then, of course, we have to think about our networks. How do we organize networks around that spatial segregation between those different zones? We also have to think about the modes that can be accommodated on these networks. Are we exclusively going to think of vehicles? Are we going to make provisions for pedestrianized areas? Are we going to think of more active modes such as cycling? How do we manage large unit vehicles, large trucks that tend to move from ports or industrial areas to other areas within the city? And how do we manage mass transit, or how do we incorporate mass transit? And then, of course, the next thing that we have to think about is the movement of these different modes. Do we restrict them to particular areas in the high street of our urban spheres? Do we want it solely to be a pedestrianized area? Do we want to incorporate cycle lanes? Do we want to limit the movement of these large unit vehicles at what times or on what roads? And then we have to ask ourselves the question, what does our streetscape look like? Right? In certain spaces and in certain zones, are we going to have it purely concretized? Will it have concrete medians? Will it have vegetation? What are the provisions for walking, for cycling, and all those aspects? And then, of course, that goes into what the quality of life is for persons that move within these urban spaces and that operate within the built environment. Does it improve our productivity when our roads allow for movement of vehicle? Does it reduce the impact on the environment as well when we think about the types of fuels that we use or the amount of congestion that happens within our road spaces? And then, of course, we have to understand what types of economic activities are being facilitated within our urban spaces. So what really is the vision for the city? And how does transportation play a role in defining what that built environment looks like? And in writing down or in understanding what that vision is, we then have to sort of audit what our existing landscape looks like, and then we have to bridge that gap. And that gap can be through design, through analysis, or through policy. But I want to implore that whichever route we take, whether it is engineering design, whether it is analysis, whether it is policy, that there are three particular tenets that we have to focus on, and that is sustainability, inclusivity, and accessibility. Now, I think it is in the 1990s, somewhere in Germany, they developed an approach called the avoid, shift, improve approach, where essentially for the avoid, we want to reduce the need for trips. So if we can build or have our built environment in such a manner, spatially set out, where we don't have to take certain trips, how can we move our essential services closer to the people that need it? How can we move the shop closer to the person that needs to go to the grocery store? How can we access certain necessities without having to leave our homes? So we avoid making trips. Right? And that reduces sometimes the networks and the space needed for things like roads. We don't have to widen roads as much as we do now. Then we also have to think about shifting in terms of the type of modes that we use. So again, if we do have to make that trip, do we have to get in our vehicle and join the congestion and cause emissions? Or could we make it more accessible so that we just have to perhaps walk down the road or cycle down the road? So we shift the type of modes that we tend to use. So we move away from vehicles and perhaps even move to public transport or more other mass transit alternatives. And then the I to improve. How can we improve the modes that we use if we have to use them? So if we are using our vehicles, what type of improvements can we make so we reduce the impact on the environment? Some of these things that we have to consider. And of course, with Jamaica, there are a number of challenges. We have to consider the vulnerability of our infrastructure. It has been mentioned again by two previous speakers, especially when it comes down to climate change and the impact that has not only on the built environment when it comes down to our road infrastructure and our road networks. I mean, I don't need to go through many examples, but that is definitely one issue that we have to, or one challenge that we face. We have to think about maintenance of this infrastructure. We have to think about as well road safety. We have to think about our response to urbanization. Many persons are moving towards the city centers. How do we accommodate the increased traffic levels? What is our response to that? Is it a demand management situation where we we think about the demand side of the equation, or is it a supply side where we think of building more roads? And we also have to think about motorization and motor vehicle dependency. Do we want to perhaps prioritize mass transit rather than vehicles? And then we can understand what the change in our built environment will look like if we make those changes. So the considerations we should have: a lot of mapping and data collection is needed. That is one of the primary pillars for any type of engineering or planning, which sometimes in this space is very lacking. A lot of modeling, and it doesn't always have to go with traffic. We have to consider modeling for active modes, walking, cycling, for public transport, as well as the overlapping of models such as flooding and other disasters, and what that impact is like on our road networks, and to see what critical aspects of our prioritization should be for some links within our network. We have to think about different mass transit alternatives and what the multimodal linkages will be between moving from walking to your bus or to your personal vehicle. We also should consider decarbonization of transport, as well as the inclusion of intelligent transport systems and automation in general, how automated vehicles or connected vehicles can impact how we design and build our networks. And of course, the Internet of Things and things such as mobility as a service, where we can plan our trips from our home so that we know exactly where to go, how to get there, and that essentially will change the fabric of our society and how we move from one place to another within our city. So these are some points that I think should incite thinking for how we move forward with our built environment and how we think about transportation, how that affects the building of our networks. Thank you.
Thank you very much, Mr. Tai. I think one of the things that people find a little hard to grapple with is this idea that cities haven't always looked the way they are now, and at some point in the future they probably won't look anything much like they do today. The thing that's probably the single most important factor in shaping cities as they are now is the dependence on private motor transport. And over the whole idea of living in one part of the city and driving to work in another depends on private motor vehicles. It's been estimated that when autonomous vehicles, fully autonomous vehicles, become widely available, that we could take probably 70 to 80% of all the vehicles off the roads and still get the same people and freight movement that we do now. Now, in that case, of course, the whole reason for having commuter belts disappears, and cities will reshape. The question is, therefore, and this is for the last 10 minutes, can we do this in a more deliberate and conscious manner to try and take into account the fact that we are maybe heading into a world of greater energy and resource constraints with more severe environmental limitations? Can we actually take this into account and do some decent forward-looking planning? The floor is open for your comments, reactions to any of the points that have been made this morning. Please keep your interventions brief. This is not an opportunity to make a speech from the floor. If you wanted to do that, you should have volunteered to be on the panel. So, comments, interventions, and above all, questions to the panel. The floor is open. Where are you?
Next side. Over here.
Over there? Oh, beg your pardon, looking in the wrong direction. Yes, please, stand up, or just wave, thank you.
So, Mr.
Use the microphone now? Yeah.
For Mr. Tai, I was wondering if what you spoke about a while ago with having everything within close proximity to each other it sounds like a concept I've heard about called a 15-minute city. So I was wondering if it's basically the same thing.
Thank you. Good question.
Yes, thank you for that. Hear me? Thank you for that question. I mean, it is based on that principle, because essentially what you want to do, as I said, it is shifting in the grand scheme of things, where we look at the economy of transportation. We have the demand and supply side of things, where, as I mentioned, the supply measures that we tend to implement is the wide enough roads to accommodate more traffic. But the demand side of things is how we manage the actual demand for travel. And having a 15-minute city is one of those ways that we can manage, perhaps not the number of trips, but the length of trips that we make. So definitely is one of the measures that can be implemented. Again, it is not a solution that may fit all cities. Kingston definitely, I will have to look on how that is modeled, but it may not be particularly suitable, especially since there isn't a specific central point to the city that radially you can move 15 minutes in each direction. Kingston has been set up in a odd fashion where movement is haphazard throughout the city, so that may not be achievable here. I mean, some aspects probably, but fully for Kingston, that may not be achievable. But it definitely is one of the demand management strategies that can be implemented in urban spaces to reduce the length of trips.
Thank you very much indeed. Would any of the other panel either of the other panel members like to just quickly comment on this issue of how cities might reshape over the next several decades? Your microphones are beside you.
Morning again. I think part of our challenge is how we think, or how we used to think. Because normally when the research comes to bear and the engineers and the architects makes recommendations that will have better life cycle costs, quite often the clients say, no, the upfront cost is too much. I don't want to do this. I don't want to do that. I made recommendations, for example, to say that if you're right up against the coastline, then it will be better if you have a concrete roof. Now, traditionally, the entire highland have a roof that is not concrete. Slowly now we are seeing architects are beginning to integrate, and you're coming up with sexy and attractive designs that have concrete. So it can be done. The issue about waterproofing, there are different waterproofing component elements that you can utilize. The size of the window, the location of the window, the type of the window, and all of this. So it's going to take not only the research from the professionals, but a change in culture also, because we seem to be operating ignorant of the possibility of the danger. I didn't try to frighten you with all of those costs, and that's the reality. It happens every year. And there are countries, I remember what happened in Dominican when we were making the report, and the Prime Minister fell in his seat. Because when he flew over Dominica and saw the devastation, he wanted to have an understanding how long would it take to rebuild the country. And I said to him, well, take how much money you spend on construction in 1 year and divide it by the cost to repair, and it will tell you how long it will take. He did not like the number, but it was reality. So we really have to wake up to what is happening and don't wait until it happens to start doing the repair, but we need to be more proactive and get into more prevention and mitigation. We need to be very conscious of the impact of climate change and what is happening all over the world. It's not a Jamaica thing, it's everywhere. We spoke about the Atlantic hurricane season, and there are sometimes in the beginning of the season, you would not have a hurricane. That happens now. There's sometimes when we wouldn't have rain, we have rain. There's sometimes when we're expected to have rain, we don't have no rain. So we have to be we have to make a conscious, cultural, and mental transformation. I sat and spoke with the owner of the house at Caribbean Terrace. And I walked past the man about 5 times a day. I didn't know that he was an owner. He looked to me like a madman. So we are missing also the effect on mental health when we have these events. There is no data, there's no figure, there's no cost. What you saw was just a raw number of the devastation and the damage. But there are long-term effects when one of those systems touch down.
Thank you. The cost of building sea defenses looks prohibitively expensive, except when you realize that on average, the cost of building the sea defenses is 5%, maybe 10% of the cost of the damage that you suffer the first time the city floods. and then it starts to look very, very cheap. Ms. Thompson. Yes, it's on. We'll get back to you in just 1 second, please. Ms. Thompson.
I would definitely say it needs to be a change in mindset, but it also needs to be a change in how we look at and receive technology and information. As you said before, a lot of these things we're going to have to do on our own, or we have to change the mindset of depending on others and depend on ourselves. And what you also see, especially in terms of research, is there are a lot of people who have local knowledge who probably have solutions. Maybe the solutions probably need to, be made sexy, according to the concrete design. And when you can get creative ideas locally in terms of how to solve some of these issues, but we don't like to reach out first to what we can get locally. And sometimes we don't trust local expertise. I think we also need to change that mindset and try and find our own solutions, try and come together as Jamaica and as a region, or even when we partner with other maritime universities to find and to partner together to find these solutions.
Absolutely. We need more creativity now than ever before. This will be our final question. Ma'am?
Good morning. Willam A. Johnson. I'm from the Bahamas. I thank you for your presentations this morning. I have a question for the gentleman who talked about the storm surges and the rest of that, because I saw his research only extended up to 2009, I think it was. We had Dorian in 2019, we had Joaquin in 2017, where some of our islands were totally devastated. Have you looked at any research from those storms, or do you know of any research that has been done from those storms and the impact? Because the storm surges in Abaco and Grand Bahama are like 15 to 20 feet. And so I don't know if you have done any research in that regard, but I know the practices in the past, when we had buildings, they were built on stilts.
Time.
Okay.
In terms of capturing the damage, yes, the information is available. I had to rush through the presentation and we selected specific events. Yes, but the problem you face is the same problem we face because we're islands. And so all the recommendations and the observation that I've made is not for Jamaica, it's all over, it's everybody.
Yes.
I hear that, but I would have liked to have seen some of the responses in your presentation, and that's why I'm asking you, in terms of persons who actually experienced that. Similar things, but I know the mental that he talked about is very important.
Okay, thank you,
well.
ma'am. Good point. Okay, ladies and gentlemen, I am sorry, but we are now out of time. Thank you for the very pertinent questions and comments, and please join me in thanking our panel. Thank you very much, guys. Great job.
Climate change, the built environment, and its sustainability. It's all about our action and inactions. Thank you very much, Professor Clayton and members of the panel. I think we've been informed this morning what is needed from us as individuals to achieve one of the 17 United Nations development goals. Thank you once again, Professor Clayton, for taking the time out to join with us this morning. Once again, kindly help me applaud them. Let me welcome the next panel to be chaired by Dr. Delroy Chevers. To join us up here are Dr. Stephen Rhoden and our Dean of Faculties of Engineering and Applied Technology, Peter McCarthy. Where's Peter? Please let them feel welcome, the CMU style. Thank you. I will introduce the chair of the panel, and he will introduce the members of his panel. Dr. Delroy Chevers is a former senior lecturer of operations management and information systems at the University of the West Indies, Muna campus. He was the Associate Dean of Graduate Studies and Research in the Faculty of Social Sciences. He holds a PhD in Information Systems from the University of West Indies, and his research interests are software processes improvement, information systems, quality and success, project management, and operations. And beyond the classroom, Dr. Chevers boasts an impressive blend of academic and industry experience. He brings a wealth of practical knowledge to his teaching, drawing from 23 years of valuable industry experience at Alumina Partners of Jamaica and Desmond Young Company Limited. You see why we tag our conference Industry Conference. It blends academics as well as industry experience. Dr. Chevers is now a senior lecturer in the Faculty of Shipping and Logistics and General Studies Department at the Caribbean Maritime University. Please let us welcome Dr. Chevers to the podium.
Thank you, Prof. Good morning, ladies and gentlemen. The title of our session is Artificial Intelligence and the Future of STEM. I expect that this session is going to stimulate a lot of questions. Artificial intelligence is so topical, it is so relevant at this time. It has implications for students and lecturers in the teaching and learning process. It also has implications for employers and employees in the business sector. And so we have two distinguished presenters who will present their work in this particular area. And as I said before, I expect a number of interesting questions. I am, as Prof said, I am Delroy Chevers, Senior Lecturer at CMU. I would like to state the protocol with respect to this session. We ask each presenter to present their work in 15 minutes, and then we ask some questions after. At this point, I will share the bio of our two facilitators. Firstly, we have Dr. Stephen Rhoden. He's currently a senior lecturer in the Engineering and Applied Technology faculty at the Caribbean Maritime University. He has over 20 years of combined experience in industry and academia. So again, we're seeing the mix with academia and industry because this is an industry conference. He is also a certified energy manager and has performed many water and energy audits for various sectors of the industry. Dr. Rhoden is also a lifelong member of the Association of Energy Engineers, committee member on the Palisades Port Royal Protected Area Management Committee, counselor on National Council on Ocean and Coastal Zone Management, a commissioner on the National Commission Science and Technology, and he is the CMU Internal Procurement Committee Chairman. At this point, I invite Dr. Rhoden to present his work. Please give him a round of applause.
All right, good morning, everyone. All right, so I'd like to thank everyone. I'd ask you to just give yourselves a round of applause, please. Thank you for being here, students especially. So today I'm here to talk to you about artificial intelligence. More directly, there was a paper that myself and Ms. Foster wrote in 2020 towards this end when we were looking at the looking at the Caribbean and how it perceives artificial intelligence. I did have a couple of videos that I wanted to show when I'm lecturing, when I'm teaching. I think we learn. A lot of persons are visual learners, and these videos really would have shown, just how far we've come. There are a lot of integration of automation and robotics into our everyday lives now, even if we don't believe it, right? So the videos would show, robots just running around the room by themselves, different industries. I had a brother that worked for a Chinese solar panel maker called Jinko Solar, right? And it just has this robotic arm, and all this robotic arm does, it just keeps passing panels to another arm. And it doesn't stop, it does that all day. But this is industry, right? And then you may have seen videos of Amazon, and they have the different robots that carry your packages to where they need to go. But it's integrated. So we're going to give you an introduction, an overview. We're going to talk about the benefits, how much adoption have we actually done in the Caribbean, the different sectors and the roles that they play, if the policy is there, because this is a very ethical concern. Persons are worried about, the takeover that these robots are going to do, right? Taking your jobs, for example. What are the best practices? We've visited some places. Some persons here may have been to the Panama Canal and, actually visited Manzanillo International Terminal, and you would have seen 90% automation on a port. Right? And so this is where we are. And this is the Caribbean too, right? So some challenges, limitations we're going to talk about, and then, conclusion and further work. And as I mentioned, this presentation, it follows from a paper from the World Hospitality and Tourism Themes that was published in 2020. So I won't give the Webster Dictionary introduction on what is AI, but just to preface it is just that it's really created by man, and it's supposed to be able to learn by itself, and in essence becoming an expert in a certain area, right? So even when I talk about those robotics and they're moving around the room, they're looking for efficiencies. They're trying to use less energy to do the same job, right? That's where we are. The term artificial intelligence and automation is becoming very prevalent. I think a lot of persons now, they have apps that you can download, such as ChatGPT on your phone, and it becomes an extension of you. One of my friends likes to talk about that cyber-physical realm that we're in, where we now have to adopt virtual avatars of ourselves and have that represent us in certain spheres. So the components of AI include machine learning, natural language processing, computer vision, robotics, and expert systems. All right. So some benefits that we can garner from artificial intelligence: warehouse efficiencies, better logistics forecasting and planning, reduction of operational costs. I think this is a major area that we need to look at, especially for our region, where, you know, if we compare ourselves to North America and Europe, the productivity level that we have within the Caribbean and the Latin American region is very low by comparison. And automation and artificial intelligence is a way of, you know, reducing those operational costs, enriching data quality, and also on-time delivery. So overall in the presentation, or during the time that we were collecting the data, you know, we really looked at different sectors that have a lot to do with the shipping and logistics sector in the Caribbean. So we questioned different groups or different populations, you know, depending on the sector. And, you know, we looked at how, you know, adoption of AI is coming along, right? So you see that there's a few people that are disinterested. The majority of us are curious, right? We want to know, you know, what's going on. How is it going to affect our lives? Is it going to make our lives easier? Is it going to be more difficult? Is it going, you know, because as I mentioned earlier, a lot of persons see it as an adverse thing. You know, they see it's going to take our jobs. You know, I'm not going to be able to operate in the same space as I am. But, you know, I think we need to move past that, right? And actually now, you know, be, well, happy, right? Or excited about it. So next question, whether artificial intelligence and automation would make your job easier, right? A majority of people, I think, here do believe yes. All of us believe yes, right? Anybody says no? You said no, though? Yeah. It should make your life easier, right? But then again, there are certain persons that would still believe no, right? Of course. And that's fine. So training, over time, persons are going to, you know, we have to change the mindset, especially as a faculty of engineering and applied technology. We have to have, you know, the training that allows persons to now be comfortable with this kind of technology. Next question, whether the company is planning to automate its system, right? And, you know, we have about 32% saying yes. Or am I seeing it correctly? Okay. No, 33%, yes. 31% said yes. And I don't know is 36%. So figure 4, this is indicating that 65% of persons had knowledge that artificial intelligence and automation are being used internationally, and 35% did not have any knowledge at all. So there's a big gap there, right, in persons that don't understand it or aren't trying to. So we've come upon now the 3 industries that we mainly spoke to during this study. The first one being the Port Authority. Right, and the ports in Jamaica are governed by the Port Authority of Jamaica, which is responsible for the safety of all vessels navigating the ports of entry and regulation of the tariffs charged on goods passing through the public waters. So yesterday we saw a presentation on mass autonomous shipping, right? Autonomous surface shipping. And so this is another important area. Have we started to create the policies, or, you know, have persons get the knowledge to be able to now have an autonomous ship navigate itself into our waters and navigate itself out safely, right? Next, we looked at the Shipping Association of Jamaica, right? And the Shipping Association of Jamaica is another key stakeholder in our shipping and logistics sector. The Shipping Association of Jamaica is a service provider to the ports as well as to other related members within the maritime sector. And finally, we looked at one of the best practices, right? Of course, our own, let's go back 1 second. So, okay, inadvertently, I skipped the slide on the Caribbean Maritime University, and it doesn't want to go back. So, but everyone knows that training and understanding and development of curricula that can actually train our personnel, right, our people, to the challenges that we are facing. Okay, so it's jumping around. Okay, there we go. So the CMU, so I spoke about it. All right. So the best practices, as I mentioned earlier, some persons may have gone to Colón, Panama. You may have seen the Manzanillo International Terminal. It really opened my eyes to what is possible, because this is a port that is controlled 90% by robots and automation and AI, right? The only intervention part that the human has, well, there's two actually. One, they have a control room where they monitor everything. Two is the drivers. That's the 10%. The drivers drive up, they pick up whatever load, whatever TEU, whatever is passing through that port at that time. And that's the only intervention that the human has in there. So it's really interesting. If you do get a chance, I would tell you definitely go and visit and see what's happening. All right, so here we're talking a little bit about what's at Manzanillo International Port. So they have the electronic data interchange standard communications platform for the exchange of data between customers and the terminal. The integration of all key components of the gate transaction, and a highly flexible platform accelerates door operations, minimizes truck processing time, and increases the productivity. An interactive system based on a web platform that facilitates remote access by customers to transactions and relevant information pertaining to their containers. And of course, this is all in a specific space on the port, so they use global positioning systems, RFID, any way that they can actually identify these different commodities that are moving through. So some challenges and limitations that we see, right? A lot of them have to do with security. And if you're thinking about it, a robot is usually programmed, or our AI is usually programmed to be a certain way, usually non-malicious. It would be the programmer that makes it malicious, right? So, security is a big thing though. And I mean, even something I saw in the newspaper the other day, speaking to Jamaicans having access to the beach. And I'm wondering to myself, how much of having access to a beach is a security risk? Because we have to be careful about what's coming in onto our shores, right? So it's something that we can think about, right? But security is definitely going to be one of the main problems that we have, right? Our risks associated. Some other limitations, right? Reliability, the environmental impact that's expected. Who chooses the vendor for this? And this is coming from a procurement mindset that I have to have now. Who chooses the vendor? Right? These things are important because we want to have, our security, we want to have our sovereignty, and then these things are going to be, actually us to some extent relinquishing that. All right, so some conclusions and further work that we'll be looking at. AI and automation are beneficial, definitely, to the shipping and logistics sector. Having, the masses understand and educated and trained and ready to be, integrated into this new paradigm. Personnel working in the logistics sector need to be aware of AI, because based on this, if we still have persons who aren't comfortable, who aren't, ready to adopt it, or they don't have the knowledge of it, it's going to be problematic. And then, down at the end, most companies within the logistics sector in Jamaica have been preparing to implement AI. But once again, there is reluctance to adoption. And so this is something that we have to overcome. Here are my references. I really would like to say thank you to Ms. Marsha Lee Foster. I don't know if she's here in the room, but a lot of this, the presentation, the document that was written, the journal article, and it's garnered about 20 citations since 2020. So it seems to be pretty important. So thanks for your attention, and have a great conference. Yeah.
Thank you, Dr. Rhoden. Our next presenter is Peter McCarthy. He is the Dean of the Faculty of Engineering at the CMU. He holds a degree in digital technology from the University of the West Indies. I would like you to welcome Mr. Peter McCarthy.
Good morning, ladies and gentlemen. Yesterday I was standing here in a different capacity. Today, I'm honored to be standing before you to speak about this very interesting topic of artificial intelligence. I will use the first part of the presentation to look at the technologies that exist currently now, as well as research work that we are doing at the university in this area. And then the last part, to look at how artificial intelligence will impact both present and future supply chain management. All right, artificial intelligence. The important thing to note here, and I won't go through the definition again because I think this term has been defined before, but it's pretty much trying to design machines that can mimic the behavior of humans. And therefore, what we try to do is to study the human brain, how it functions, and then we try to design electronic circuits and the software that can mimic the way the brain processes information. And put that in a machine, and then we use that machine to accomplish tasks that human beings would normally accomplish. The central technology behind this, and note I have the first point there, centralized intelligence, which simply means that you have a centralized hub that control is done from. So in other words, we have cloud computing, we have server farms, and these are large data centers where these machines can tap into to get information. Also, there is an issue as it relates to processing power. And based on the current technology, it requires supercomputers that are large and are not necessarily that easily portable. So because of that, we tend to, at the moment, be focusing on centralized intelligence. But the AI of the future, and this is my proposal, is that it's going to be largely decentralized. In other words, more like human beings, where we don't have to tap into a central system to get information every day, but we are able to take the information around with us. I'm not sure what is happening here. Now, this is very important that we look at the development of computer chips that are capable of handling large or storing large volumes of data, as well as has significant amount of processing power. I'm trying to go back. And to ensure that these chips are small enough that they can be integrated into these products. At the current moment, using EV technology, we are down to about 3 nanometers in terms of chips. And the trend is to go down to 1 nanometer and possibly into the picometer range. Now, it's becoming more and more difficult to do that. And eventually, the question that may be asked is, how small can we go in terms of these chips? So one of the things that I've been looking at is that if we're really going to be able to solve this issue of chip size, then we have to look at changing the current technology. And so the research that we are doing is to look at what we call memory enhanced neural networks. So instead of using just the basic neural networks that incorporates forward propagation, back propagation, and deep learning techniques, we look at the human brain. We are born with about 100 billion cells in our brain. And as we grow older, we lose some of those cells. But what is interesting is that each neuron in the brain has about 10,000 dendrites attached to it. And these dendrites can each attach to another neurons. Now, information through the brain is carried or is propagated using these neural net pathways. What we find is that throughout your lifetime, you are storing information, you are processing information continuously. But your brain never gets to the state where it cannot store any more information. And what is interesting here is that you don't have to increase brain cells to increase your memory capacity. In fact, while you are losing brain cells, you still have the capacity to still store. So I did a little mathematical calculation using the combination formula to see the number of possible combinations of connections within the brain. And there on your screen, you will see it as 100 billion factorial over 100 billion minus 10,000 factorial into 10,000 factorial. If you try to calculate that number on your calculators, it will give you an error. Okay, it won't be able to handle that number. So it gives you an idea as to how powerful the human brain is. And if we are going to replicate that, it means that with current technology, we'll not be able to do that. We'll have to change it. And so what we're looking at, instead of storing information in terms of blocks of bits, ones and zeros, we compress that into mathematical formula and store the information as a mathematical formula. And then when you need to process the information, you pull back these formulas and carry out mathematical operations on it. And that way, you're able to store a lot more information in these. In fact, if we're able to achieve that, it means that we could design a simple chip that can store an nearly infinite amount of data. Mind you, we are in the preliminary stages of the research. We have done a lot of the mathematical and some of the software development works. I deliberately omitted the mathematical formulas here. But this is just a flowchart to show what we are working on. In fact, where the technology is now is just the first two blocks that you see in this diagram. So the other blocks that are there is what we are proposing in this research. Another part of the research is to develop memory functions, and this is an example of one such function that we will use. We are experimenting with other such functions where the value of these functions are bounded, and so we develop a wrong scan matrix, which we call a memory matrix, that will multiply the output matrix from the sigmoid decision block there, and this is where you get the expansion of the mathematical formula back into bits. Time will not allow us to go through all the technical details here, but what this does, it gives a lot more storage capacity, so you could use a regular chip and store a lot more data than the current 3 nanometers, 5 nanometer chips that we currently have on the market. The retrieval would be much faster because you're pulling less data, and there's a possibility that you'll have faster data processing. This will allow us to design fully automated AI systems that does not need to be centrally controlled. This system will be able to fully carry out all the functions that we do without have to tap into a central network. What is the implications of this for the logistics sector? And just to say quickly that the landscape as it relates to global logistics is changing. The COVID situation and now the war in Ukraine is causing a lot of countries to look at building more resilient chains. So I mentioned the short train and long train logistics, which pretty much is the short chain logistics is a case where they're looking to have the entire train either in a trading block or sometimes in a very narrow geographical region. So you can avoid choke points around the world, as well as if there is a disaster in one part of the world, it doesn't affect economic activity in other parts of the world, as what had happened with COVID and now what is happening in Europe. And in the long train logistics, this is a case where you have several nodes that are located right across the globe. Now, using AI, there is definitely going to be less need for human, both physical and intelligence in the workforce. This simply means that there's going to be a drastic reduction in the need for both skilled and unskilled labor in this, well, not just the maritime industry, right across all industries. The question is, what do we do with these people that are going to be displaced? And this is something that we need to start looking at, especially as a training, as a university. How are we going to shape our curriculum going into the future? AI has made it and will continue to make it very easy for information to be had by persons. So even in the case of assessing students, teaching students, assessing students, what I'm seeing coming out of this is that a lot of the core information that we are teaching our students now, we may not need to teach them that in the future. So the question is, what are we going to teach them then? Because we're not going to need that large pool of maritime specialists, because AI is going to be doing a lot of these jobs. Most of our ports are going to be fully automated. Our ships are going to be fully automated. And this is not going to take us 30, 40 years. It's going to be arrive much earlier than that. And so, while we try to comfort ourselves that don't fear AI and don't worry about AI, it's something we really need to think about very carefully. And many persons may have to, in the medium to long term, look at career change. Because these systems will be able to process information much faster than humans can. They will be able to carry out tasks with a high level of precision and efficiency, much more than we can. So we will have to, from a policy perspective, start looking as to how we are going to be dealing with this. We talk about border security, which we will eventually see become fully automated. And if we have AI policing our streets, the question may be asked, how do we determine what force they use against our citizens who they may have to arrest or charge? This is going to happen in the future. So I think the biggest challenge that we now need to be looking at is how do we transition from what we have now to what we are going to have to deal with in the future. AI is here to stay. It's only going to get better and better. And as a university, we are trying to ensure that we are out there and we are becoming a part of the research in this area. We have a program at CMU in AI and computer systems, and we want to ensure that Jamaica is not left behind in this area. Yes. So at this time, I'm going to conclude, and I just want you to think about what is next for us in this industry.
Thank you, Peter and Stephen. And Peter's left $1 million question with us. And so at this point, I'm inviting the audience for questions. Yes, you can turn on your mic.
My question is for Mr. McCarthy. So you spoke about AI and taking over jobs. In your research, did you find any particular qualities or anything that the human beings would have had an advantage over technology?
All right, there are some areas that is still proving pretty difficult to replicate. Emotions is one of them. How do you program emotions into a machine? We have done some amount of advancement in areas like cognitive computing, but we are still a long way off where that is concerned. Human beings are nonlinear, meaning it's not a case where the same stimulus being applied to everybody will give the same response. And that is what makes the world interesting. That is something that we are trying to implement in AI systems, but we are not there yet. We are still going to need persons with background in computer science and engineering, definitely. And so as it relates to STEM, that's an area that we have to take very, very serious. because a lot of the jobs in the future are going to be in that area.
A follow-up question.
Okay, thank you for your response. I like your response, right? So are you saying that then we can have different types of jobs? So maybe what we should be looking to in the future is not to think that we are going to lose our jobs, but to be creative, to find new jobs to work along with our technology as well. Do you think that could save us?
That is exactly what we need to do. There is a discussion in a number of places about whether eventually we may have to retire the entire human workforce. And then government just pay everybody a salary based on the profits made from the work done by these machines. So there is talk about that, because it is true that we are going to get to this point where a lot of the jobs we now have are going to go.
Hello. Oh. Hello, morning.
Yes.
Hi, I also have a question, and this is for Dr. Rhoden. In the research that you did, was the cost of energy ever a limitation for the integration of automation?
Okay. Can you hear me? Yes?
Yes.
So to be honest, we did not look at that in our studies. All right, thank you.
Hello.
Well, okay.
Hello. Sorry, I came in late, let me confess. But I just have a general question. I don't know who exactly would answer it. But we have been looking at a lot of things about AI and machine learning and all of this, and it seems as if they're aiming to take over. First thing, the people who make these things are concerned. So the sci-fi movie about AI taking over and eliminating us seem to be real enough. So the people who invent these things are concerned. The other thing is that, do we discuss our continuity? Because AI don't spend money, right? They don't shop, they don't engage in some of the activities that keep society and economies going. So where does this fall in the discussion?
All right. It's a valid concern about what AI will do in the future. I still don't think that they will be able to eliminate humans, even though some people have that concerns. To fully replicate the human brain in a machine is light years away from us. We are going to be able to approximate it to a certain extent, but if you remember the calculations that I showed you earlier, just to give you an idea, all the data in the world put together is measured in zettabytes. And we are, I think, approaching a little around 100 zettabytes of data internationally. That is a very small amount of information compared to what the brain theoretically can store. So we are still far off where that is concerned. So there will always be a place for human beings. We will not eliminate ourselves. And AI will not do that for us either.
I have another question, if you're able to.
Oh, yes. Proceed.
Okay, so this question is for Dr. Rhoden and Mr. McCarthy. So in the presentation, it was said that these organizations are looking to integrate artificial intelligence into their systems. Is there any that is currently using it right now? And do you have any information on how you think they are receiving the technology? Is it that they're finding that it's difficult to learn, or is it easy to use and making everyone's lives easier? Thank
All
you.
right. AI is being used extensively across the world in almost every aspect of life. We even have AI soldiers now that is being tested. In Jamaica? It's used a lot in Jamaica. The chat GPT that students use is an AI product. When you go on the internet to purchase something, and in fact just to browse, and you realize that when you go back, certain pages keep popping up. It's that there's an AI running in the background that is tracking your activities and making recommendations based on what you had looked at before.
True.
In fact, there's a case where a lady found out that her daughter was pregnant because she realized that her daughter, when she goes on her daughter phone, there was a lot of baby, things for babies coming up because the daughter was searching online about baby clothes and that kind of stuff. And so the AI picked that up. And so every time, you go on YouTube or one of those social media sites, things about baby start popping up. And she recognized that, well, something must be wrong. Why my daughter is searching for baby things? So it is used right across the world. There is no place on earth that you don't have AI being used now.
Okay, thank you. At this point, we will take one last question.
Sorry, Chair. Chair, 1 second. Mind if I answer as well? I think she asked both of us. All right, so to speak specifically to companies, each company knows their business. They would wish that they could actually know what next steps to take, what types of technology are going to actually advance them. But the majority of them aren't trained. They have personnel with very low skill levels, not necessarily that, they're not productive as they should be and based on their level of knowledge, and that, artificial intelligence could assist them. But, once again, yesterday you saw a presentation on a 41-year-old beverage manufacturing company, mom and pop company. We can't expect that they're going to be experts in this field, right? And especially it being so new. And each business is different. I was talking to the chairman of the Port Management Association of the Caribbean, Mr. Telemac, earlier. And we're speaking to the challenges of ports and in the Caribbean, and each one is different. Each one is different. So it's really it's not necessarily a holistic approach where we can broad brush, but I think a lot needs to go into our policy and how we ethically adopt it. All right, thank you.
Thank you, Peter.
I have a question for Mr. McCarthy.
Go ahead.
Is there, going forward in the future, is there a consideration for introducing programming to high schools?
As far as I know, programming is introduced at the primary level.
At the primary level?
Already. Yes.
Already.
Yes, and I know for all engineering programs at CMU, programming is a must.
Mm-hmm. Yeah, but some high schools don't do programming.
I think there's a shortage of qualified programmers out there to fill all the teaching vacancies. But eventually, we have to get to that point where we have enough of those persons, because programming is a skill that is indispensable at this moment. Even though we have AI writing programs for you, but there may be some specific things that you need to do to make a piece of software work the way you want it to work, as well as when you're building, especially enterprise level software, there are many pieces that you have to put together. And so sometimes the issue is not in writing the individual pieces, but it's linking all of those pieces and getting them to work together. And that is where the programmer is very important.
Thank you, Peter. Thank you, ladies and gentlemen. And okay.
Hello, good day, Mr. McCarthy. I've seen your work before, and I'm very interested. However, what I would like to know, if you ever come across work on designing your AIs with ambition, I think that is one of the driving forces behind us humans that allow us to achieve more than what we are. And if you could program into a machine the desire to get knowledge that it doesn't have before, or create knowledge, then if you ever seen any work like that, that would be interesting.
That is already in train. And this is where, again, cognitive computing comes in. So we are already designing systems like that. Probably not at the level of a human being, but we are getting close there.
I think that is also the danger part as well.
Right.
Okay. All right. Thank you, ladies and gentlemen. Thank you, Peter and Stephen. Okay. All the best.
Some years back, when Manzanillo International Terminal had the plan of introducing AI into their operations at the largest terminal in this region, in Panama, there was an outcry from the community of Manzanillo that jobs will be taken away from people. But they educated the community that rather, it will provide more jobs. Because at Manzanillo International Terminal today, cranes no longer move containers. Containers are moved from the computer in the office. The trucker goes in there, he drops it, and they move. And the surprising thing is that we saw what happened here yesterday. Women in Maritime. 80% of people employed to move containers now at Manzanillo International Terminal are female. Because what they do is to queue your containers. If you miss by 2 minutes for your truck to be there to pick your container, you have to go and join the queue again. And that may take a couple of days. And as Peter said, we now see autonomous, our captain presented on autonomous vessels yesterday. We are still going to continue to produce captains, but captains will be here in Jamaica moving vessels from China to the Caribbean. I saw an advertisement some time ago where a captain announced to the passengers on a flight, "This is your captain communicating with you from home, and I will be flying you from this destination to the other." So that is where we are moving into. So rather than begin to think that AI is going to take our jobs away, but rather it's going to provide more jobs. People will have to write programs. People who have to develop hardware and software and all those things. So to me, it's more jobs. What it means is that we have to accept the changes that are coming to us. We have to retool ourselves. We have to re-engineer ourselves. Panel, thank you very much for that insightful presentation. Please give them a warm round of applause again. Thank you. Yeah, we will hand over your gift to you later on. At this time, we are going to be breaking for coffee break, but before we go for coffee break, we're going to come back, witness the signing of the MOU between the Caribbean Maritime University and Olusegun Agagu University of Science and Technology. After which we progress to our presentation before lunch. But before we move, I want to use this opportunity to recognize Dr. Zaria Malcolm from Excelsior Community College, who is here with us this morning. It is exactly 3 minutes to 11, and our coffee break is from 11 to 11:15. So you have additional 3 minutes to grab your coffee break and come back to us. Thank you very much for being an excellent audience this morning. Prince of Brown is coming with you. Ladies and gentlemen, we're just waiting on the media.
Check.
Ladies and gentlemen, that moment we've been waiting for, the endorsement of an MOU between two institutions, the Caribbean Maritime University and Olusegun Agagu University of Science and Technology from Nigeria. President Spencer, VC Temi, this is the moment we've been waiting for. And immediately after this signing of MOU, we move into our next panel discussion. So, ladies and gentlemen, I want to hear and see a round of applause for the two heads of these two institutions. In the usual way, I think our president knows it very well. He must have signed almost over 20 MOUs, within the last few months. So I'm going to invite the two of them to sign the MOUs, and our Vice President, Academic Affairs and Accreditation will witness the signing of the MOU. So, gentlemen, yeah. Please go ahead, President.
Okay, thank you. So, very briefly, just to say, Vice Chancellor, welcome. This represents the very heart and soul of what the Caribbean Maritime University does. We are a partnership university. We have multiple industries equally important to us. And so we are excited about this moment because we understand that this is one of those things that will move us forward, move you forward. It is not in any way, shape, or form intended to be yet another MOU simply written and signed for the purpose of optics. There is substance. there's depth, and there's the need for that forward movement. So I'm happy to be able to sign this MOU with Olusegun Agagu University of Science and Technology. And interestingly, the fact that you're a science and technology university means you're an automatic fit for the Caribbean Maritime University, as we are maritime, but we are the technology hub of the Caribbean. So thank you, sir. I know you may have a few words as well.
Thank you very much. My president, for us, is another milestone because we are looking at what we call 2+2 program as we sign this MOU, such that our students will spend 2 years in Nigeria and 2 years in CMU. That's the kind of vision we have. And this MOU is just the beginning of this greater journey. Thank you very much.
So you can now go ahead and sign the document. In a marriage ceremony, after the couples might have kissed themselves, they will have to go in the back of the room to sign the certificate of engagement. But this time around, we're not doing that. We want the whole world to see the signing of this MOU. So time to shake hand now. Congratulations, CMU, congratulations, Olusegun Agagu, University of Science and Technology. And I believe the next step here is for our president to visit Nigeria. Oh, yeah. Thank you, gentlemen. Ladies and gentlemen, thank you very much. So we're moving right into our next segment before lunch. You shouldn't be hungry now. We just came back from a coffee break. And I am assuring you that the person who is going to share this session manages time very well. Dr. Andrea Clayton, please come for me. Mr. Small, Dr. Anderson, Keaton Logan, kindly join me up here. All right, solutions for food and water security. And it's going to be shared by Dr. Andrea Clayton. She's Principal Lecturer of Sustainable Development at the Caribbean Maritime University. She also serves as the Caribbean representative for the Governing Plastic Network, the Director of the Earth Ambassadors Organization, and a recruited member of the Commonwealth Climate Change Research Cohort. Dr. Clayton is a member of ECOP, a network of ocean professionals, an association of Commonwealth Universities alumni, and a notably published academic and documentary producer. Her research and publications focus on systems thinking and applications. human capital development, the blue economy, marine litter, and the problem of plastic pollution and ocean health. Dr. Clayton holds a doctorate from Temple University, degrees in economics and economic development, and she's a notable published academic and documentary producer. Ladies and gentlemen, please help me welcome Dr. Andrea Clayton. Thank you.
Good morning. It's still morning, right? And I have my clock here for my presenters. It's been a wonderful 2 days, a day and a half so far, and I'm expecting that it will only continue to be better. As was mentioned earlier, this session we're looking at solutions for food and water security. Now, many of us don't know this, so I'm going to just use my time to share a little information, but World Food Day is celebrated on October 16th. And this year, the theme is Water is Life, Water is Food, Leave No One Behind. The theme highlights the critical role of water for life on Earth and water as the foundation for food. It also seeks to raise global awareness about the importance of managing water wisely as rapid population growth, economic development, urbanization, and climate change threatens water availability. The global food security challenge is straightforward. By 2050, the world must feed almost 2 billion more people. The demand for food will be 56% greater than it was in 2010. Today, we will hear from 3 very esteemed guests on solutions for food and water security. Dr. Kirkland Anderson will examine the cost-effective and efficient technologies for small farming sustainability in Jamaica. We have Andre Small, a mathematician, who will be looking at the peristalsis-driven flow of Ellis fluid in an inclined asymmetric channel. And we have Mr. Keaton Logan, who is a scientist among us as well, who will be looking at the potential of Sargassum byproducts for heavy metal pollution mitigation. So all of us, we've seen Sargassum on our beaches. We've smelled it as we drive out to the Palisados. So Keaton will help us to figure out what to do with that. We will take the speakers in the order that they were introduced. We'll start with Dr. Anderson, then we will have Mr. Small, followed by Mr. Logan, after which we will take questions. Thank you.
I think it's slide number 8, right? Okay. Ladies and gentlemen, good morning to you. Thank you so much. I just want to say, that now that we have had something to eat, I'm sure it's good to talk about food. Ladies and gentlemen, more than ever, the war that's taking place between Ukraine and Russia, along with some of the things that the moderator just said, more than ever, place on steroid the need for us to move from the stage where we are learning to feed ourselves and be at the stage where we are feeding ourselves. And so this morning, we'll be looking at, leveraging cost-effective and efficient technologies for small farming sustainability here in Jamaica. It's a fact, ladies and gentlemen, that 1 in 3 Jamaicans is indeed a small farmer. However, only 6.5% of this country's budget is contributed from this sector. Another important fact that we need to note is that last year alone, this country imported $1 billion worth of agricultural products, which means, ladies and gentlemen, we do have a market here for agricultural products. Now, in order for our farmers to penetrate this market, farming cannot be done the same way. There needs to be a change, there needs to be an adjustment. And so what this research does, is that it looks at utilizing aspect of technology into our farming system so that our farmers can be more productive and indeed more sustainable. Indeed, ladies and gentlemen, it is important for us to understand that this is indeed an important aspect in our country. We want to look at, how we can use both technology that are effective and technology that are efficient. The truth is, ladies and gentlemen, although both are actually identical, we want to look at them individually because our farmers in Jamaica are indeed very unique. Most of our farmers who are older in terms of age are more inclined for cost-effective technology. And the younger ones who perhaps have some educational training are more looking at the efficient side of technology. My system not working. I'm not so sure what's happening. Oh, yes, it moves now. All right. Keep going. Now, they said point it this way. In the name of Jesus, work. Let's see if it's okay now. All right. I'm not so sure. Indeed, ladies and gentlemen, what we have done is that I've looked at using a case study analysis, look at, success stories along with responses from, focus group. And we arrive at a solution in terms of, what type of cost-effective technology should be used, what type of, efficient technology is very, very important. And so there are a number of technologies that are indeed very inexpensive and likely to be affordable to our small farmers. I think I'm going to get some help here. It's not in my 10 minutes, so I can afford to wait. $12, okay. Okay. Keep moving back. What am I doing? That's what I'm trying to do. Okay. All right. Yes. So we, here we have some technology that have been used here in corners of Jamaica and indeed corners throughout the world. We have the sensor that is being used, and this sensor, ladies and gentlemen, is actually, deal with, the nature of the soil. It looks at the nature of the soil, how moist the soil is, as well as wherever there's pests, if there's any pests there. We also look at the irrigation and water management system. Again, this is also an effective method in which water can actually go to the roots of the plants, evenly and consistently. It is also used in terms of assisting with fertilizing fertigation. Again, the plants will be equally fertilized, equally nourished. And so productivity is likely to increase. I should say at the outset, ladies and gentlemen, that the main aim of using technology in our farming practice is to take the guesswork out of farming. So farmers know exactly what to do, how to do it, when to do it, etc. No guesswork is now involved, all right? We also want to talk about, in terms of efficient technology, in terms of using solar system within our agricultural practices. And again, we now have solar pumps that can generate, that can actually use to better power our drip system. Of course, it's also very, very important to be used in hydroponics. And so what you find here is that it no longer, the whole idea of using electricity will now come from our solar, so to speak. Again, the other activity involved in integrated pest management, and this involves a 5-step process, where first of all you identify the pest itself, and this is where the sensor also comes in. You identify it, and then of course once you identify it, the system will also evaluate it. In other words, it will determine whether or not this is a pest that is damaging, and how it can be controlled, and how can it be reduced to a level that it is not economically damaging. Again, what you see there, we can move to cost-effective technology, and this is where now we use things like So what we have here, ladies and gentlemen, is a situation where we can now use our greenhouse effect. Instead of using, imported material, we can now become very ingenious with our indigenous material, as our president reminded us yesterday. Of course, we can now make sure that our cost is reduced as a result of what material we are using. Of course, that would also reduce our import bills. Again, we also want to look at a micro irrigation system. Again, ladies and gentlemen, if you see there, is very, very primitive, but the government of Israel has made it possible for 600 farmers in Clarendon. They are now using a much better irrigation system, in which they now have a catchment system, and of course they have the solar pumps, and of course nutrients, water, etc., has been going to the roots of the plants in a consistent manner. So that system we have is very, very primitive, but nevertheless we are improving in that area. Again, ladies and gentlemen, you also have the what we call keeping your soil, or a system that is used to make sure that your soil is more healthy. So you're talking about using plastic mulching, and under those plastic mulching is indeed organic mulching. And so what it does, it actually keeps the nutrients, the water, etc., in the soil at a longer period, which is more beneficial to the farmers. That particular picture you're looking at, there's a gentleman from Trelawney, and he has actually boasted to the gleaner how prosperous he has been as a result of that practice. And then, of course, we have access to market information and e-commerce platform. There is a company, I think it's in Manchester, called, they produce a product called RiverFarm, and what that RiverFarm does, it gives you several different data. It gives you agronomic data. It tells you what the soil is like, how moisture it is, and it also gives you idea of forecasts, when it's likely to rain, and the testimonies from this system suggest that it's always very accurate. One more important aspect about the RiverFarm is that it tells you where the best markets where the best market is. It takes into consideration 3 markets, Clarendon market, Linstead market, and the Coronation market, and it gives you an idea where the price is best. So you as a farmer can simply just go there, go where the price is better, and so you can make more money. The idea here, ladies and gentlemen, is that farming will now become more productive as a result of the use of technology. But here is some impacts that we want to quickly look at. Again, when we focus on Jamaica, we see where the maturity of our crops on an average have decreased by 25%, which means that they are coming in much faster than before. And no doubt, once they're coming in quicker, you can sell them faster and you can make more money overall. Again, based on the crops, the productivity has increased from 15% to 200%. Farmers who are in the hydroponic business have really, expressed their delight that their crops have increased by 200%. Again, we see production costs has decreased by an average of 30%. There's a few farmers who indicated that their costs has been reduced by a maximum of 70,000 Jamaican dollars in one season. We also could talk about the fact that the water retention to the roots of the plants have really, increased for a significant period. The nutrients in the plants, all of those will remain in the soil. The soil becomes a lot more healthy, and of course, so will be the products that we actually look at. Again, everybody, this cannot happen without, collaboration from the movers and shakers in this country. And we're talking about the government, of course, the private sector. And so we have some support from the government in terms of, providing some of the farmers with financial aid. You have extension service officers like the RADA personnel who go out into the field and they train the farmers, they encourage the farmers, they show the farmers where things are going wrong and help them to correct it. You also have the land tenure and security. Here we have somewhere in the region of 400,000 acres of farmland in this country that is unutilized. And so what the government is actually doing is really to try the best to allocate lands to these individuals, or to individuals who are really interested in going into farming. All right. Again, we also have partnership in terms of private sector. We have what we call the contract farming. I think this is where companies like Best Dress is heavily involved, where they have an agreement with local farmers to produce chicken, and they would buy it. So, and there are other areas where people can sell their crops, their products straight to the manufacturers. And then, of course, we have technology adoption, where there are companies like Isra Tech, that is actually involved here too. And I have some recommendations which I will move across. But in concluding, friends, I just want you to note that the first slide that you saw is where some of our farmers are in terms of the quality of their product, but it's where all our farmers ought to be, again, in terms of the quality of their product. Quickly, I just want to show you guys that here we have a group of farmers and the activities, but the fourth one is what is important. What I'm trying to show is that farming is also wonderful, because after you have produced your crop, sell your crop, you can go river tubing at the end of the day. Thank you so much, everybody. May God bless you.
Thank you, Dr. Anderson, our economist. Now we'll have our mathematician, Mr. Small.
Hello, good day, everybody. I must first start by saying it is a pleasure to present before this audience. And before I get started, I would like to ask, have any of you ever experienced heartburn or what we describe as acid reflux? Let me see a show of hands. All right, so it turns out that work in this research can give us some insight into why that happens. So the topic that I'm presenting on today is peristalsis-driven flow of an Ellis fluid in an inclined asymmetric channel. Okay, so a layout of this presentation. Firstly, I'll be introducing the title and the topic, and then we look at the mathematical formulation of this physiological problem. We'll be solving the mathematical formulation or the model, and then we look at our results and discussions where we'll look at images of the results. Later we'll look at our conclusion and then the work that we'll be looking at in the future. All right, so an introduction. The question is, what is peristalsis? So peristalsis is a transport of fluid within channels or tubes by wave-like motions of the walls of the channels or the tube. And an example of that is, for example, drinking water, the process by which the water moves from your mouth to your stomach via the esophagus, that is referred to as, or called peristalsis. Also, let's look at this image here. This is a design of a peristaltic pump that we try to simulate that wave-like motion, and the fluid interesting, for this image here, what is interesting is that the mechanical parts of the pump is not in contact with the fluid itself. And that's one of the advantages of peristaltic pumping. This type of pump is used in like blood pumps for transfusions and dialysis machines. You'll find them in those type of machines. All right. So, some sites and applications of peristalsis. Through the entire GI tract, we'll find this process of transportation of fluid, along with peristaltic pump designs in the urinary tract, and also some earthworms achieve locomotion or its transport using this type of pumping process. All right, so the fluid model that we are going to use here is what we describe as the Ellis fluid model. It's one of the mathematical models used to describe the nature of the fluid in terms of its response to shearing forces, or what we'll describe as the rheology of the fluid. Here, tau ij is the stress tensor, gamma ij is the deformation tensor, mu naught is the Newtonian viscosity, tau naught and alpha are fluid parameters, and we use them to curve fit. We use them to fit a particular fluid type. Oh, there are two conditions. As tau naught approaches infinity, this condition converges to what we call the Newtonian fluid, and the cluster that we are seeing here, the dimensionless cluster being much greater than 1, implies that the result that we have is the fluid model reduces to what a commonly used fluid model, which is the polar fluid model. This type of fluid is a shear thinning fluid, where the viscosity of the fluid decreases as the shearing forces increase, or the velocity of the fluid increases. So in a mathematical formulation, let's see what we are looking for. We are looking for, firstly, the velocity vector fields, which are u and v in this formulation. We want to know what the velocity of the fluid in the channel looks like. We also want to know the pressure, and from the velocity, we can determine the volume flow rate. We could also determine the streamlines, what the streamlines look like, and we could also determine the stresses that the tubes will experience. So the governing equation here, give me a second. Yes, so the governing equation here are equations 1 and 2, which are the conservation of mass equation and the conservation of momentum equation. And these are provided in compact form. We are imagining a wave, the flow of an Ellis fluid in a channel where the walls of the channel are pushing the fluid forward using what we describe the walls using sinusoidal waves. So this is an image of the asymmetry that we achieve using H1 and H2, the upper wall and the lower wall of the channel. We also have a phase shift, which is phi, which means the upper wall and the lower wall is not necessarily in phase. And here omega is the center of the channel, and D1 plus D2 is the channel width. So as the conditions and assumption of this model are that we assume that the flow is in the XY direction, and the XY direction would have been had from the image that we had earlier. So the X direction is the horizontal plane, and the Y direction, well, they are both on the horizontal plane. The channel is on the within the horizontal plane. So the flow is in the XY direction, and there's no flow in the Z direction, right? In addition to that, In addition to that, the channel is also inclined at an angle theta. The fluid is incompressible also. So those assumptions reduce the compact equation that we had earlier, equations 1 and 2, to equation 3, equation 4, and equations 5. So the assumptions allow us to simplify the problem mathematically so that we can solve. All right, so those equations are subject to the boundary conditions in equation 6, and these boundary conditions are the no-slip boundary conditions, which implies that the fluids in contact with the walls of the channel will take the properties of the walls of the channel. So the wall shape is described using the sinusoidal functions H1 and H2. The upper wall is H1, the lower wall is H2, and phi there is the phase shift. C represents the speed of the wave, and lambda is the wavelength. A1 and B1 are the amplitudes of both waves respectively. So we also take what we call the Galilean transformation, in which we travel along with the wave of the walls. So the walls are traveling at a speed, we are traveling at that speed. And if we are traveling there, then what that means is that the problem becomes a stable problem instead of being unstable initially. And stable means not dependent on time. Thank you. All right, so this is an whoa. All right, what should be here? This is an example of the codes that were written for the walls, and I don't think I have the ability to press play here. It's actually a video of me running this code, and on that video, you would see the walls it's up now. So you will see the walls propagating, of the wave propagating, and this is how we create that simulation. We could do so for all the other physical quantities that we observe. Thank you very much, ma'am. All right, so the reduced equations are equations 9 and 10. That is after non-dimensionalizing the quantities and taking what we call an order of magnitude analysis to determine which forces in this flow are more significant. And it turns out that the shearing forces are more significant for this type of flow. The equations are subjected to the conditions in equation 11, and we solve this system of nonlinear partial differential equations for our results, which are U, V, P, where U and V are the transverse and axial velocity, as well as P, which is the pressure within the tube. So the dimensionless wall equations are 12 and 13, and those walls have to satisfy the condition in 14, which means the two walls should not collide, or they should not intersect. Why that is necessary is that physically we know that that cannot happen, that should not happen. So mathematically it's possible, but physically we meet that condition to ensure it doesn't happen. All right, tau yx is the last, or the only remaining shear component after non-dimensionalizing. All right, so solutions of the model. So here we have the I don't know why these colors are like this. All right, so what we have here is the axial velocity and the transverse velocity. The expressions I don't think you can see. I can't see them right now. Right, but we have the axial and the transverse velocity. Right, maybe this is a better image. And from the transverse velocity, we are able to produce the streamlines, which are described here as psi, equation 18. We also calculated the volume flow rate, which is given in equation 19. That's it. All right, let me move to the conclusions. All right, so these are images of the velocities provided. And also the pressurized per unit wavelength. Sorry. The streamlines. The streamlines. And this image here would have told us why we have that reflux situation. And in concluding, what we realize is that the fluid parameters doesn't have as much impact on the transverse and the axial velocity. The angle of inclination, it also doesn't provide or doesn't have that much impact on the pumping process as well. This process actually works if you're upside down. If you try to swallow something, you're upside down, you will still be able to swallow if the transportation process will still be possible. All right, so all right, let me finish. So my future work, let's look at that. I would like to look at peristaltic transport of an Ellis fluid in a finite length tube, and also we'd like to look at work in bifurcated tubes, and we'll also want to look at working with distribution of a solute within a solvent in the future. All right, so thank you very much. I'm sorry for running over your time.
So Mr. Small wanted 15 minutes and he got 15 minutes. So now we'll have Mr. Logan, who is our Sargassum expert. So let's hear him.
Good, it's afternoon now. Good afternoon, everyone. Such a wonderful opportunity to be here. I must thank the CMU Industry Conference for this wonderful opportunity, as well as recognize the distinguished guests. So for today, a lot of pressure has been added to me to speak about Sargassum. And Sargassum, a lot of persons know Sargassum as a problem. But today we'll be examining Sargassum to see if it's actually a problem or can it be a solution. And we'll also look into the potential for heavy metal bioremediation as well. So if you've been to a particular beach in Portmore, and I won't call the name, Elsha, you see? It's giving away already. It's giving away already. You might have seen large masses of brown seaweed on the beach and also in the water. And it's not just in Portmore, but I just specified there because I went there one day to enjoy a nice day on the beach, and I had to turn back because of what I saw. Not only because of what I saw, but the smell as well. It was truly terrible, right? So I left that day. That was a good while back, and I'm sure it's the same situation today. But thinking on that situation that I had, it intrigued me. I wanted to know what this brown mass of seaweed was, and upon investigating that, we found that this is actually called Sargassum, and Sargassum is a genus of large brown seaweed. Now, Sargassum pointer. No. Okay, good, very good. So Sargassum is often located in the tropical and also the temperate oceans worldwide. Not only that, it often floats. So if you realize when you see Sargassum, it doesn't attach to the seafloor at all. It floats along very conspicuously. However, Sargassum does provide a habitat for marine organisms. So while it does provide a habitat for some marine organisms, the problem with Sargassum is it often accumulates in large abundances, whether in sea or on land, and that is where we find the problem with Sargassum. So when Sargassum accumulates in the sea, it causes a lot of issues. So first of all, it can wreak havoc on ecosystems. It can also smother coral reefs, and it can also affect the water's pH balance, and that will affect all marine organisms in the oceans and also the waterways that you find it. On land, we have a similar issue. On land, I think it's a bigger problem on land for majority of people, because what actually happens is that it chokes local economies. It chokes local economies, and not only that, it can also result in a closure of tourism sites. Some sites that you might love, you just the sargassum on it. The next day, you can't enjoy that again. And it also constricts fishing yields. So, a couple of solutions have been given for sargassum. Some persons suggest eating it, right? Why not just eat sargassum? I'll tell you, sargassum is no callaloo, right? Sargassum, in some areas, some persons, for instance, in Asia, some persons actually do eat sargassum, but there has been research that links a correlation between heavy metal bioaccumulation in individuals and the eating of sargassum. So that's definitely not the route we want to take. Can we make drink from it? We do from red seaweed, we make Irish mash, but it's the same as eating it, right? It enters your body. Some persons suggest burying it, burying the living dead. Just burying it, out of mind, out of sight. That's what they recommend, right? But I refuse to believe that such a large mass of seaweed was here. And the best solution that we could have is bury it. I refuse to believe that. So in collaborating with Dr. Raquel, right, who is a senior lecturer at CMU at Marine Biotechnology Department, we opted to explore the potential benefits of sargassum. And what we found is that after looking into sargassum, we realized that sargassum had a large amount of abundant alginate. And alginate won't mean anything to you right now, but in a bit you'll understand why it's important. So alginate, you can think of alginate like a more liquidy form of jello. It's also very biocompatible and it's low in toxicity. So let me just skip, the pointer is not right. Right, so this is how we actually extract our alginate. So first, we collect our sargassum, we dry the sargassum, we mill it, and of course we apply an alkaline extraction. I won't be going into detail with this extraction method too. It's a simple method, but it's very nuanced when you think about it. And afterwards, we purify the alginate, and what we end up with is a slurry, for lack of a better word, of sodium alginate. But that's not the final product. That's not the final product. So afterwards, if it's one day I regret having a lot of transitions, it's today. So after having our sodium alginate, we add our sodium alginate in a drop-like manner, and this is an area where we can actually ensure that we have a more streamlined production of alginate beads, because what we do with the sodium alginate is to create beads, as you can see in the image there, by adding it to calcium chloride. So this is actually the technology. Seems simple. It seems very simple, but you'll see how remarkable it actually is, especially when we look at the bioremediation potential of or alginate beads. And just a quick look at what is happening with the bead formation process. So in the image on your left, yes, your left, your left, you'll see a backbone and you'll see some Na. That's actually the sodium. That's how that's the makeup of the sodium alginate. And when we add it to our calcium chloride solution, it becomes solidified. So you have a cross polymerization. So that's actually what happens. So now we want to apply this technology. So we saw that sargassum is actually a problem, right? And we created a potential solution. So now we want to apply the solution to see what we can do with our sargassum beads. So we opted to look into heavy metal bioremediation. And when we think about heavy metals, we're not thinking about going to the gym and lifting up weights. We're thinking about metals with high atomic weight and density, such as lead, mercury, cadmium, arsenic. You might be familiar with arsenic. These compounds, they exist in nature. However, I don't want to say a man-made disaster can increase or exacerbate its presence, but that is often what happens when you have, for instance, arsenic pollution and cadmium and mercury pollution. So we see heavy metal accumulation. It can affect the air, it can affect the soil, and definitely it can affect our water sources. And that's a very important thing that we'll be looking at today. So, right, so heavy metal pollution in our water sources, it goes without saying that this poses a direct health risk, especially when you think about, fishermen. They go to fish, but if these waterways are polluted with heavy metals, it can bioaccumulate in the fish, and then when you eat the fish, it gets inside you, and that can truly pose a great risk, and it can lead to death. It can lead to death. You think about the Kingston Harbor, for instance. It's not unknown that there is pollution in the Kingston Harbor, especially with heavy metal, waste from ships, and so forth. And we all know about the Rio Cobra incident. We should know about the Rio Cobra incident where you had that spill, and also heavy metal was also involved there as well. So we wanted to look how we can remove some of these heavy metal from our water sources so that we can have cleaner water sources, so that our health can be improved. So what this technology that I just mentioned, the alginate beads, do is that whenever there are heavy metals, whenever there are heavy metals in our water sources, we can apply our sodium alginate beads, and what will happen is we have an entrapment of those heavy metals. So the technology that we're proposing is sodium alginate entrapping these heavy metals in our water sources. And what we'll end up with, people, is that we have a more polluted water source, and we can end up with a cleaner and safer water source just by applying the sodium alginate technology. And of course, preliminary data that was garnered on our sodium alginate beads suggests that the Sargassum alginate beads are stable, especially at conditions around 4% saline, which is equivalent to the seawater, and at room temperature. They are also reusable because these beads are very sturdy, and it also provides a more sustainable method of cleaning up our water sources. So guys, with that, I thank you very much. Thank you for listening.
I did not have to stand, right? He still has 2 minutes. Thank you, gentlemen. Those have been some very enlightening information that has been shared. I'm sure you've learned a lot. I know I could hear from that side in particular that the mathematics formulas kind of caught them off guard. But understanding how we process the food would probably also be able to help us how we can sustainably produce some of the foods that will continue to give us nutrition. Because in the discussion about food and water security, it's not just about the amount of food we produce. It's important that we recognize it's also about producing food that is nutritious and accessible, food that is clean, water that is clean. And so I'm going to open up the floor for questions from the, straight out at the gate. All right.
Yes, thank you very much. I have a question for Mr. Small and a question for the man from Sargassum. Yes.
Mr. Logan.
Mr. Logan, so I'll go with you first. Some of the research that were being done locally looked at using Sargassum as fertilizer. I didn't hear you speak about that in your presentation. And the question I have, what are you doing with the waste? What kind of waste is produced from what you have done, and how are you disposing of those waste and things like that? And I want to know if the model you're developing, if that will help us to be able to determine how long it takes medication to travel to effective locations in the body.
Yes, definitely. You are not wrong. This ideology about using Sargassum to solve a problem, not looking at it as trash, but actually as treasure. It's not a new concept at all. As you mentioned, yes, persons have used it as fertilizers, and also persons, I think a business called Organic, they actually use it as goat feed, right?
So persons have been utilizing it. But what I wanted to focus on was the application of sargassum in cleaning up our water sources. So I thank you for that. Thank you for that comment. And yes, there are a lot of research being done on the sargassum, using it as feed. And also, when we use the sargassum to create our alginate beads, I wouldn't want to say waste from it. Often persons find that you can reuse this as fuels as well. That's also research that's being done where they use the waste from their sargassum alginate bead production to use as fuel. So that's something persons looking into. Sorry.
And again, Dr. Broomfield, thank you for that question. It allows me to elaborate a little bit more, get some more time. So the last element on the slide, future work, we are looking at the dispersion of solutes in solvents, right? The velocity vector field that we obtain in this research, we're going to use that to produce information for pharmaceuticals with drug delivery systems in terms of capsules that will rupture at different sites based on these velocity vector fields. Thank you.
Thank you. We have another question and then one from here.
Hello, my question is for Dr. Anderson. I want you to tell us if there is any type of technology apart from camera system that can help with predial larceny now, because you talk about going on the tube after you plant, you produce, but what about me watching my produce, feeling happy about planting it, and then when I go to reap, there's none to reap? That's one. And Mr. Logan, I was just wondering, based on your presentation, is it possible for the beads to be dissolved in any way at all?
Thank you so much. Yes, the truth is that this is actually a difficult situation that farmers are facing in this country. And one of the recommendations, which I didn't get to look at, was really the actually collaboration among farmers in Jamaica, where government, private sector entities are actually encouraging farmers to work together. It's actually like, you watch my back and I watch yours. But again, it's a situation that we're having serious problem within this country. Camera has to be used. You have to have farmers working together in terms of trying to watch each other crops. And there are other possibilities that are actually being looking at right now by the Ministry of Agriculture and Fishery.
Yes, just to answer the question, just so I see if I understand your question, do the beads dissolve? Okay, is it possible for it to be dissolved? Oh, okay, yes, I understand. Well, the preliminary results that we have, because we actually we place these beads in different conditions. We use them at different pH levels. We used it at different temperatures, and we also used it at different saline concentrations. And the preliminary result, just for a short period, suggests that they're very stable. And that's actually one of the things with the beads. They can be reused. So after we put these beads out, applying it in whatever matrix we choose, since it's preliminary now, we can take that out and we can reuse it. So that's the idea. But so far, it shows great stability.
Okay, thank you. Prof. Brown.
Okay, thank you, Madam Chair. Mr. Small, my question is for you. I noticed when you did your formulation, you said you use Cartesian coordinates. You said you're on the XY plane, so it's a 2D flow. And then, but when you are developing, I realized that you kept the gravity component, because you have in the X equation, you have G sine theta, and in the Y, you have minus Gy sine cos theta. Why do you keep the G if it's a T2D flow? Why was gravity important in it? And then after you answer that, maybe you could say, you could just answer or tell me, did you consider using cylindrical coordinates for your flow? Because you're talking about flow in a tube and you're using an XY solution for it. It would be more, you know, for you to use like cylindrical coordinate to solve the problem. Thank you.
So I get the question. The reason why we look at flow in channels and then make reference to tubes is that for channels the problem is a bit easier to solve, and then we can go into tubes, right? So we look at channels first and we get the information and say, okay, this is how we approach a problem mathematically. And then now, currently I've worked on flows in tubes, right? So the other question, remind me? Yeah, the first one. Oh, the gravity. All right, so the channels could be inclined, meaning let's look at a canal, for example, going over a hill. Then the forces of gravity would, although it's not in the Z direction, you're still pumping against gravity. So, for example, a canal just going over a hill where the walls of the canal can pump the fluid forward.
Thank you. Okay, any more questions from the audience?
Just Mr. Anderson. I enjoy the fact that we are infusing technology in farming, right? But how are you going to? You know the situation that we are in. So you put in these solar pumps and then.
Can you speak a little?
You put in these solar pumps and then how will you protect them from being stolen? So the farmer puts in these things and then they are stolen the next day.
Okay, with Dr. Anderson, I think it comes back to some of what he said earlier about the farmers watching each other and using cameras.
But they also, excuse me, but they also remove them at the end of the day if needs be. Yeah, so they're not there permanently. They are movable.
And so the thieves can move them more quickly. Okay, all right.
We thought about drones. Drones were ever.
Okay.
Yes.
All right.
Yes. The reason why I didn't focus so much on it because only a few farmers have been using that. As a matter of fact, I've come across only about 2 farmers in Clarendon that are actually using the drone, and they are really having very, very, very good success. You know, so
Okay.
drone is actually used. Yes.
All right. So I'm going to take one question from Dr. Morrison. And who is that question to?
Oh, Andre.
Oh, Mr. Small.
All right. Andre, I think you did a very good presentation. But for persons who are not mathematically inclined, what I want you to do is just explain
in English
language. Yes. So you say it's peristalsis, right? So if it is that I am putting anything in my mouth, tell me what happens and what is the solution that you gave that can make you not have heartburn.
Okay.
Yes.
So again, thank you for the question, because this is always an opportunity
to expand
clarify.
on your.
There was a slide on the presentation that showed us the streamlines, and from the streamlines we can calculate what we call the volume flow rate and the direction of the particles, the fluid particles. So when you swallow maybe a mouthful of water, the fluid is transported from the mouth to the stomach via the esophagus. The entire GI tract functions like that. It turns out that inherent in the pumping process is a phenomena called reflux and trapping. So the reflux occurs at the periphery of the tube. So if we took a look at that slide, then we will see the velocity vectors showing the direction of the fluid flow that will indicate to us why we have that reflux. The conditions necessary are that we should have an adverse pressure head, meaning the pressure in the stomach is already greater than the atmospheric pressure, And if the sphincter muscle at the base of your stomach is weak, which happens over time, I realize that since recently, I've been experiencing, right? So what happened is that now the fluid, based on just the pumping process, the fluid should stay down based on gravity, but the pumping process alone has that reflux phenomenon inherent in it. I don't know if I clear it better.
All right. Okay, so as I'm a stickler for time, and I know we should have been at lunch from 12:15. They always give me a basket to carry water, people. I have two long questions. I'm just going to read them out, and if you're interested, you can come back to them to hear the response, but I'm going to close the session after. But I too had two questions, and one of them is for Dr. Anderson. In light with the UN's target for ending hunger, achieving food security, and improving nutrition, particularly in keeping with the SDGs, the 17 SDGs. And this is by 2030, which we're only 7 years away. We know that from 2014, there's been an increase in the number of people suffering from hunger and malnutrition. What I want to know, especially in a country like Jamaica that we're so dependent on imported food, in your study you looked at technology with the production of food, but how has market access featured in your study, and how could permaculture and organic farming systems be integrated for food and water security? So that's my question to Dr. Anderson. And my question to Mr. Logan has to do with agricultural soil. No, that's a non-renewable. I know a lot of people think that soil is renewable, but in our lifetime, it's quite a non-renewable natural resource because it will lose some of its properties. So you have to carefully steward over it. We know since industrialization, agricultural practices and industrialization has been detrimental to our soil health. So Mr. Logan, a lot of Sargassum studies have focused on coastal areas. My questions, how could integrating what you're proposing with profitable and sustainable land use help to remediate some of these food and water challenges that we're having? And what are the research challenges and future directions for the study that you're looking at? Okay, so those are my two questions. But since it's never a good thing to stand between people and them food, I am going to close the session, and if you're interested in hearing the answer to those two questions, you can stay. But you have my permission to leave.
Can join us at lunch.
Okay. All right, ladies and gentlemen, it's lunchtime. You should be back. So lunch was scheduled for you to come back by 1:30, and you should come back by 1:30. You have 45 minutes.
All right, thank you. All right. Thank you.